I am Dr. B.J.D. Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about the addressing modes. At the end of this video, the student can able to understand what is addressing mode, how it can be different with various varieties that are available, and how operand can has to be fetched with these addressing modes, and some problems related to the addressing modes. The basic agenda of this video is introduction regarding the addressing modes, what are various categories of addressing modes, and how the problems can has to be framed based on these addressing modes. Whenever a user want to perform any function with the computer, the user required to submit the program. A program can be considered as collection of instructions. So each instruction is generally categorized into two parts. One is the opcode, second part is the address. So here the addressing mode is the method of specifying the operand. So where from this the instruction is generally specifies what operation is to be performed, but on which data this operation can be performed, either on a CPU register or from any memory location, that can be specified by the addressing mode. So the part of the instruction is generally consisting of the opcode. The opcode specifies what category of instruction it could be. Either it is a memory referenced instruction, or a register reference instruction, or an IO instruction. So based on this, the functionality required data has to be provided with the help of CPU registers or with memory locations. So where this operand can be located can be specified by using the addressing modes. The purpose of using addressing mode is to give the programming versatility to the user. So variety of addressing modes are there. By using this, the location of the operand can be specified in a versatile way to reduce the number of bits in addressing field of the instruction. So the addressing modes generally used for these purposes. So the way any operand can be selected during program execution can be depending upon the addressing mode of the instruction. So here the major purpose of the specifying addressing mode is it has to specify the location of the operand. And here a variety of addressing modes are available. They are implied addressing mode, immediate addressing mode, register direct addressing mode, register indirect addressing mode, auto increment or decrement mode, direct memory addressing mode, indirect addressing mode, relative addressing mode, indexed addressing mode, base register addressing mode. Here basically 10 categories of addressing modes are there. We will discuss one after another, each mode with examples. The first addressing mode is implied or implicit addressing mode. So the definition of the instruction itself specify the operand implicitly. So during the instruction specification itself involves the specification of the operand. That's why the name implied or implicit addressing mode can be given. So the operands are directly specified instead of their addresses. So it is also referred with another name called implicit addressing mode. So in this mode, how the operand can be specified? It is directly available with the instruction. Implicitly, it is available with the instruction. That's why the name implied or implicit addressing mode. Take example of add 7. and here the 7 is the data that has to be taken directly. Add is the instruction which is used to perform the addition arithmetic operation. So the 7 data has to be added with the accumulated data, and the result is stored in the accumulator. So here the data is directly available within the instruction. That's why this is called implicit addressing mode. Another example is CMPB. So comparison has to be done with the help of the CMP instruction. So the B register value has to be compared with the with this accumulator. Next, INC AC. INC is used to for incrementation operand. So here the register value can be incremented by 1 with the help of INC. So INC AC accumulator value can be added by 1 to the existing accumulator value with the help of the INC instruction. So in this type of addressing mode, the data can be directly specified along with the instruction. Next category of addressing mode is immediate addressing mode. So in this addressing mode, the operand is part of instruction instead of content of the registers or memory location. So in order, it can avoid the referencing of the registers or the memory locations. Since the data is encoded directly into the instruction, immediately the operands are available to perform the operation on the data. So immediate operands normally represent constant data. So here the format of the instruction in the immediate addressing mode is, first the opcode has to be represented, next the operand can be specified. So here the operand is directly available in the instruction format itself. So here the examples are add R1, 50. So here the data can be available. So the 50 is added to the content of the register 1 and the sum is stored in the register R1. So here next example is MOV, moving the data. So 70 is moved to the accumulator. So 70 accumulator is initialized with 70. So in the immediate addressing mode, in the instruction format, instead of address, the operand has to be directly available. Next is register direct addressing mode. Here in this mode, the operand to be accessed in the CPU registers. The operand is available in the CPU registers. That's why register direct addressing mode. Actually, all computers are usually provided with some addressable registers. Depending upon the processor, the number of registers can be varied. The general purpose registers are generally denoting with R0 to Rn-1. If k bits of the operands field can be denoted, any one of 2 power k registers operand holding the data word. So here in case of register direct addressing mode, the opcode, what is the instruction format that has to be specified here. Next the operand is R4. So here the operand 1 is referring to the register that is the available on the CPU. So here operand 1 is referring to the register R4. In this, the first operand can be stored for the instruction add, and operand 2 is available in the register R3. So here the second number is stored in the available in the R3. So register referenced CPU architecture majorly uses the register direct addressing mode. So here the opcode specifies the instruction. The operands are available on the CPU register. So that's why this is called as register direct addressing mode. How we have to give this addressing mode with examples. So here add R1 comma R2. Addition operation can be performed on the data stored in the registers R1 and R2, and the sum is stored again in the R1. So next example is INC R2. So the R2 CPU register value can be incremented by 1 with the INC instruction. So this is the register direct addressing mode. Next variety of addressing mode is register indirect addressing mode. In this addressing mode, the address field of the instruction refers to the CPU register that contains the effective address of the operand. So in the previous case, in the instruction, what is the operand has to be specified, so that data is available at the register itself. But in register indirect addressing mode, the operand can be specified the register. There it contains the effective address where actually the data is located, that has to be specified. Only one reference to memory is required to fetch the operand. So here operand and the register number. In this register, the memory address has to be specified where the operand can be available. So in the previous case, the operand, what is the register specified here, at that register itself the data can be available. But in case of register indirect addressing mode, it has to refer the register where the memory address of the operand can be located. So the system has to refer to the memory location to fetch the operand. That's why the name register indirect addressing mode. How we have to represent this? Add R1 comma R2 has to be represented within parentheses. Instructions has the R2, where R2 in the register R2, one memory address has to be stored. The system has to refer that memory address in order to locate the data. So this memory address specified by the R2, what is the data is there, that data is added with the data in the register R1 and the sum is stored in the R1. So in this way, the register indirect addressing mode can be used. So what is the difference between this direct addressing mode and indirect addressing mode? So in the direct addressing mode, the operand is placed in the general purpose register itself. But here in the indirect addressing mode, it is placed in the memory. The register has to specify the memory address where the actual data has to be located. Next, in register mode, address field contains the effective address of the operand. What is effective address? Where actually the operand is available, that address, memory address is called the effective address. In the direct addressing mode, the register, what is the register specified in the instruction, there itself the effective address has to be specified. But in case of register indirect addressing mode, it can contains the memory address. The register can contains the effective address or the memory address where the data can be available. It requires only one register referent to access the data. But in case of indirect, two register references in order to access the data. So here one movement has to refer, the register number can be referred. In this register number, memory address is there. Again, this register has to use it to refer the memory location of the data. So two movements has to be required to refer the actual data. So no further calculation required to perform the operation. But in order to get the actual data, calculation is to required to find the effective address. Register addressing mode is fast and register indirect addressing mode is slow. Why? Because two references it has to needed to locate the data. It is easier to access the data in the register mode, but it is somewhat complex. Effective address need to calculate to locate the data. It uses temporary variables, but it uses the pointers in order to locate the data. So these are the differences between register direct and register indirect addressing mode. The next variety of the addressing mode is auto increment or decrement addressing mode. So in this addressing mode, the operand address get incremented or decremented automatically for each access to the operand data. So here the registers can has to be specified with to implement the increment operation with the plus sign and to implement the decrement operation with the minus sign. What is increment operation means? The existing content of the register can be added with a 1 during incrementation, but it is subtracted with a 1 during decrementation respectively. So here the incrementation and decrementation can be pre-increment or post-increment. Pre-increment means the plus sign can has to be specified before the register, and post-increment means it is suffixed with the register name. So here in the pre-increment, first the incrementation operation on the register can be performed. That address can be used to refer the operand. Post-increment means after referring to the memory location, then the register content can has to be incremented. So similarly, pre-decrementation and post-decrementation can also be used in the auto increment and decrement addressing modes. So we will consider few examples. Here load R1, R2 plus. So here first the R2 value can has to be increased to the size. The size is specified by the D, and then it has to load the value to the R1. So similar way, here add instruction is used to perform the arithmetic addition operation. So here R2 value can has to be incremented with the size of the D, and that location can has to be used to receive the content of the second number, and it can be added with the first register value, and the sum is stored in the R1. Next, decrementation can also be applied in the similar way. So here pre-decrementation operation is used. Here the sign can be specified before the register. If you are observed in the previous examples, after the register content, the sign can be represented. So it is post-incrementation. So here the R2 value can has to be decremented, and it can be it has to be loaded with the R1 register. So similarly, the arithmetic operation can has to be performed by using the add operation. So in this way, the auto increment and decrement addressing mode can be used. So in this mode, the plus sign or minus sign can has to be specified, prefixed or suffixed with the register in order to represent whether it is a pre-increment or pre-decrement, or post-increment or post-decrement. Next is direct addressing mode. So in this addressing mode, the address field of the instruction contains the effective address of the operand. So in the instruction format, the opcode and address can has to be specified. The address whatever specified in the instruction is the effective address of the operand. So this is also called as absolute addressing mode. and only one reference to the memory is required to fetch the operand. Why? Because the effective address is specified within the instruction itself. So here the opcode, here it is the address. This is the effective address of the operand, where the operand, actual operand has to be located in the memory. So the another name of this is absolute addressing mode, and the symbol that is generally used to denote this direct addressing mode is square bracket. So here examples are load R1, 100. 100 is the memory location where this operand can be available. Add AL, and the memory location can be specified within the notation by using the square bracket. So this is the direct addressing mode. Next is indirect addressing mode. As we observed in the resistor direct and resistor indirect addressing mode, here also in the direct memory location reference, we are having direct and indirect addressing mode. Here what is the address that is specified in the instruction can reflect the effective address. There another moment of that memory location can be needed by the system in order to identify the operand. So the address field of the instruction specifies the address of the memory location that contains effective address of the operand. But here in the direct case, what is the address specified? That is itself is the effective address. So two references to the memory are required to fetch the operand. Here one reference is from address to the effective address. Another second reference is from effective address to the operand. That's why two references to the memory are required to fetch the operand. And it is generally denoted with @ or parenthesis symbol. So here how to apply this indirect addressing mode is add R1, @100. So at the 100 memory location, the effective address is there. Another memory location is specified. There the computer has to move in order to identify the operand. So this is the indirect addressing mode. So now we'll see what is the difference between direct addressing mode and indirect addressing mode. So here generally the instruction format has to be specified with opcode and the address, and the MSB has to be represented whether it is a direct addressing mode or indirect addressing mode. This 15th bit is 0 means it's a direct addressing mode. If I value is 0 means it is a direct addressing mode. If I value is 1 means it is a indirect addressing mode. So here this represents either it is a direct addressing mode or indirect addressing mode. Now consider an instruction, add instruction, and the address specified in the instruction is 457. In case of I value is 0, it is a direct addressing mode. So here what is the address specified in the instruction itself is the effective address of the operand. So at the location of 457 memory, the operand can be available. That operand is used for the addition arithmetic operation. So plus operation can be considered here. This operand along with the accumulator content can be added and the result is stored in the accumulator. In case of direct addressing mechanism, so the address that is specified in the instruction itself act as effective address. So in case of indirect addressing mode, when the instruction format I value is equal to 1, it refers it as a indirect addressing mode. So in the indirect addressing mode, add and the address that is specified in the instruction. Here in this example, we considered it as 300. At the 300 memory location, the effective address of the operand can be available. So here the system can make a move, refer the memory. So at the 300 location, the 1350, this is the effective address. So the system has to refer one more memory location in order to identify the operand. So here 1350 location, if the system is moved, there the operand can be available. That operand is used in the addition calculation with the accumulator. So this is the indirect addressing mode. So here this is the difference between direct and indirect addressing mode. So here after, what is the process difference between direct and indirect addressing mode? Now we'll see with the basic parameters what actually the difference between direct and indirect addressing mode. First, with the basic concept that we discussed with an example here, how the operand has to be fetched in case of direct and indirect addressing mode. The first parameter that can be considered is the basic concept. So in the direct addressing mode contains the concerned operand in the instruction code address field. But in case of indirect addressing mode, the operand address stays the address field of the any instruction. So two memory locations can has to be referred. So the address that is specified in the instruction can reflect the effective address of the operand. How many total number of memory references can be required in order to fetch the operand? It requires no memory references for accessing data directly. Effective address is specified in the instruction, but it requires multiple memory locations for switching of an operand. Generally, two memory locations, memory references can has to be used. Space required for address. It makes use of comparatively smaller space than the indirect addressing mode. But in case of indirect addressing mode, it makes use of comparatively larger space than the direct addressing mode. Again, the effective address has to be stored. So the more space has to be required for the indirect addressing mode. No additional calculations are required. Why? Because the effective address is directly available with the instruction. But in case of indirect addressing mode, effective address calculation can be required. Additional overhead, no additional overhead. Why? Because directly the operand address has to be mentioned in the instruction, but it requires some little overhead in order to locate the operand. Process speed is the direct method is comparatively faster. Direct accessing of operand has to be possible with the address specified in the instruction. But in case of comparative with the direct mode, indirect mode is somewhat slow process speed with the direct mode. So these are the basic differences that exist between the direct and indirect addressing mode. The next variety of addressing mode is relative addressing mode. So in this mode, the effective address of the operand is obtained by adding the content of the program counter with the address part of the instruction. So whatever address specified in the instruction format, that address has to be added with the PC program counter value in order to gain the effective address where the operand can be located in the memory. So effective address is equal to content of the program counter plus address part of the instruction. So this is the instruction which consists of opcode and the address. This address is added with the program counter address, and this what is the result that is obtained, that is used to refer the location of the memory in order to fetch the content of the operand. So that's why it is called relative addressing. The next category of addressing mode is indexed addressing mode. In this mode, effective address of the operand is obtained by adding the content of the index register with the address part of the instruction. In the relative addressing mode, the address part of the instruction is added with the program counter value. But in case of indexed addressing, indexed register value can be added with the address part of the instruction. So effective address is equal to content of the index register plus address part of the instruction. So here the index register value, that register value can be added with the address part of the register. What is the sum that is obtained? That is the effective address, and this can be used to refer the operand of the memory. So this addressing mechanism is called indexed addressing mode. And the last category of addressing mode is base register addressing mode. In this addressing mode, effective address of the operand is obtained by adding the content of the base register with the address part of the instruction. So here the effective address is equal to content of the base register plus address part of the instruction. So after opcode, the base register value, and this can be added with the address that is specified in the instruction, which will result the effective address where the operand can be available in the memory. So this type of addressing mode is called the base register addressing mode. So these are the 10 varieties of the addressing modes. So here the major purpose of the addressing mode is to locate the operand. So to specify the location of the memory where the operand is available. That is generally referred as the effective address of the operand. You can apply this addressing mode mechanism with a real world analogy of playing the games of treasure hunt. So here a treasure is placed somewhere and hints are given in order to locate that treasure. So those hints, whatever you are giving, is the addressing modes. By using this, the treasure can has to be located. Where actually it is located is the effective address. So here where actually the treasure is found, that hint is the effective hint. So like this, the addressing mechanism can be used to understand the real world analogy of the playing the treasure hunt game. So with these hints only, it is possible to locate the actual treasure. So with specifying these addressing modes, the operand data can has to be fetched from the memory. So these are the varieties of the addressing modes. Now we will discuss how the problems can become based on the concept of the addressing modes. So first one is match each of high level language statements given on the left hand side with the most natural addressing mode from those listed on the right hand side. So here is a matching question. So here the addressing modes are given here. This is one type of example, and second, third, three types of examples are given, but here the proper addressing modes are given. So which type of statement can be fixed with the which proper addressing mode can has to be matched, and here four options are given. So here the solution can be C. So here first one, consider it is an indexed addressing. So indexing can has to be used. Next, second one is increment, auto increment. Why? Because here the increment operator can be specified. Next is indirect addressing mode. So this is the first question. Generally we can observe this type of questions in the GATE exams. Next type of question is also based on the matching. So here column 1, the addressing mode is specified. Column 2, which concept can has to be used in this addressing mechanisms. So here indirect addressing, next immediate addressing, auto increment addressing is used. The concept of a high level language which has to be used to specify these addressing mechanisms. So here C is the answer. Here excuse me. So here the first one is increment addressing mode. The increment address indirect addressing mode. The indirect addressing mode is generally used the pointer concept. Next one is immediate addressing mode. The immediate addressing mode is used the next one is auto decrement mode. The auto decrement mode is generally used the loops. So what is the high level constructs has to be used in the proper addressing modes can be mapped here in this problem. Next problem is in the absolute addressing mode, the operand is inside the instruction. The address of the operand is inside the instruction. The register containing the address of the operand is specified inside the instruction. The location of the operand is implicit. So here in this case, the second option is correct. The address of the operand is inside the instruction. So absolute means it's a direct addressing mode. In the direct addressing mode, the address of the operand can be specified within the instruction. Next problem is which of the following addressing modes are suitable for program relocation at the runtime. So here absolute addressing, base addressing, relative addressing, indirect addressing can be given. So here based on the base addressing and relative addressing, the relocation can be done at the runtime. Why? Because in the base addressing, base register value can be added with the address in order to calculate the effective address of the operand. So relocation can be possible. Next, in case of relative addressing also, the address of the instruction specified in the instruction can be added with the program counter. So relocation can be possible in case of base addressing and the relative addressing. Next is what is the most appropriate match for the items in the first column with the items in the second column. In the first column, the items that are specified are indirect addressing, indexed addressing, base register addressing. In the high level languages, what are the proper constructs that can support these addressing modes? So here array implementation, writing relocatable code, passing array as parameter. So these are the high level language mechanisms. So these mechanisms can be chosen as appropriate indexing mode. So here is the first one is the answer. So here indirect addressing mode, the passing array as a parameter. Okay. Next, in case of indexed addressing mode, array implementation. Indexing mechanism can be easily done in the array implementation. Base register addressing mode, relocation can be possible with the base register addressing mode. In the previous problem only we discussed. So here base register value is added with the address specified in the instruction. Thereby relocation can be possible. So here the answer can be which of the following addressing modes permit relocation without any change whatever in the code. So here indirect addressing, indexed addressing, PC relative addressing and base register addressing. So here without any change whatever so in the code, the relocation can has to be supported. So it can be the base register addressing. So like this, in various competition exams, what are the various high level constructs generally used for these addressing modes and how the way the addressing modes can has to be represented, that can has to be matched. Next type of problem is consider three-word machine instruction. So three words can machine instruction. The instruction is add and two operands can be specified. The first operand uses indexed addressing mode. So this is used fetched by using the indexed addressing mode. R0 is an indexed register. The second operand uses @B uses indirect addressing mode. @ symbol is used, it's an indirect addressing mode. A and B are memory addresses residing at the second and third word. So the first word of the instruction specifies the opcode, the index register designation, and source and destination addressing modes. During execution of the add instruction, the two operands are added and stored in the destination. So here the first one is used to store the result. What are the number of cycles needed during execution of this instruction? Okay, so to execute this instruction, how many number of cycles are required? So the options can be given 3, 4, 5, 6. So this is the instruction. So the first one is indexed addressing mode. The second one is indirect addressing mode. So for the first operand, it uses the index addressing mode. So one memory cycle is used to fetch the instruction. Next, for the second operand, it uses indirect addressing mode. In case of indirect addressing mode, first the address specified in the instruction specifies the effective address of the operand. So two memory cycles can be required in order to fetch the operand. After fetching these two operands, they can be added and the result has to be stored in the memory. So it requires the one memory cycle. So in first case, the one cycle. In second case, it is a indirect addressing. Two cycles can be required. And in the third case, performing the addition and storing the result, one cycle can be required. So totally 4 cycles can be required to execute this instruction. Next, consider a hypothetical processor with an instruction of type LW R120. So this is the instruction which during executes read 32-bit word from the memory and stores it in 32-bit register of R1. The effective address of the memory location is obtained by addition of the constant 20 and the content of the register R2. Which of the following best reflect the addressing mode implemented by this instruction for operand in the memory? A constant 20 has to be added with the register R2. So the addressing modes are immediate, register addressing, register indirect scaled addressing, base indexed addressing. So 20 is the constant, base has to be added with the content of the register. And first, the effective address of the memory location has to be obtained by the addition of a constant 20 and the content of register R2. So it is a base indexed addressing. So in this way, the problems can be framed in the addressing modes. So in this video, we discussed about what is addressing mode, what is its need, and here what are various varieties of addressing modes. We are having basically 10 varieties of addressing modes. What are the basic features of each variety of the addressing mode by giving with examples. And during direct and indirect addressing modes, what are various differences we discussed. So for easy remembrance of these addressing modes concept, the student can remember the real world analogy of the playing the treasure hunt game. and how in various competition exams the problems pertaining to these addressing modes can has to be given, how they can be solved with numerous examples we discuss. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.